So add and simplify. Well, radicals do work just like variables, where you can only combine them if they're like terms. In this case, like radicals. To be a like radical, what's under the radical sign has to be the same, and definitely not the same. However, I can simplify both of these individually. And if by chance I get like radicals, then I can combine them. So right now, I can't add them. I can't say, oh, well, that's the square root of 84. Just add 9 to 75. You can't do that. Because that's really not 75. That's the square root of 75, which is going to be 8 something. 8 point something. And that's not 9. That's the square root of 9, which is actually 3. So that's why we can't combine them. If I simplify them individually, square root of 9 is 3. And then we could just simplify the square root of 75. Now, I'm probably not going to be able to combine these, but I do need to at least simplify my answer. And actually, we already did square root of 75. It ended up being, what, 5 square root 3, I think? Since we just simplified that one a minute ago. Remember, it was, we did 25 times 3, and the square root of 25 is 5. Now, this is my final answer, and I will tell you a lot of people, I see this all the time, they're like, oh, okay, so my final answer is 8 square root 3. No. That's not 3 times 5, or 3 plus 5. That's like if you had 3 plus 5x. Could you combine that? No. Okay, you can't combine it. Because they're not like terms. Same reason for our radicals. Same reason why we can't combine those. That's the most simplified we can go. So 3 plus 5 square root 3. Alright, so that's 18. Let's look, okay, not 19 because that's going to be I. Okay, so here's an instance where we do add, and they are like radicals. They both have the same square root too, so we can go ahead and combine them. Just like if it was 9x and 4x, we could put them together. And we put them together the same way. 9 plus 4 is 13, so I have 13 square root 2. So they work just like variables. You just add their coefficients together. And that would work for subtraction as well, of course. All right, let's do 22 then. Since we're right here.
Do that because the two's matched.
Uh-huh.
Okay.
2's matched on that one, so that's why we were able to do it on that one. And 22 has square root 11 over 2. And it says rationalize the denominator, and we have square root 11 over 2. Now rationalize, that's kind of a big word. All it means is we need to simplify. We can't have a fraction under a radical and be simplified. So that's a big issue. And I'm like, okay, well I can fix that problem because I can give each of them their own little house. I don't have a fraction under a radical anymore. But I can't have a radical in a denominator. So there's 3 things. When you are simplifying radicals, you can't have a fraction under a radical sign. You can't have a radical sign in a denominator. And you can't have a perfect square factor under the radical. So that's why we like with the 75, it wasn't simplified because we could break it down to 25 and 3. So I can't have a square root in the denominator like that. So the way we get rid of that is, well, how do I get rid of square roots? If I make it a perfect square and I can take the square root of it, then I don't have a radical sign anymore. So that's what we're going to do. So we are going to multiply the top and the bottom by the same thing because you know mathematically that won't change the value of it. And we are going to do square root of 2 over square root of 2. Now what that's going to do for me is when I multiply straight across, let's see where I get square root 22 over square root 4. Square root 4, that's a perfect square. I created a perfect square so I can take the square root of it. And that's going to give me, what, square root of 22 over 2. Does 22 break down any further? No. I mean, if you tried to break that down into factors, it'd be 2 times 11. I can't ring up two things that are the same. So this is my final answer. Square root 22 over 2. That is simplified. It meets all the criteria. Square root of 22 won't break down. There is no longer a fraction under a radical, and there is no radical in a denominator. And we call it a radical sign and not a square root sign, because if they wanted the cubed root, we'd use the same sign just with a little 3 in it. So that's why I'm calling it radical, and I know some of you guys have never heard that term before. Okay, the first thing we have to talk about is where I comes from and what it stands for. Okay, so a little bit of a history lesson here in case you're wondering. Not even really history, just kind of where it comes from. Have you ever put in your calculator the square root of a negative number and you get an error message? Have you ever done that? So like we have, let's say, with just a regular square root, I'll just pick on 49. I think we can all agree that the square root of 49 is 7. But did you know that 49 actually has 2 roots? Because 7 times 7 is 49, but negative 7 times negative 7 is also 49. So we have, and if they want the negative root, they'll put the negative, delay. They'll put the negative out in front. So square root of 49 is 7. The negative of the square root of 49 is negative 7, because negative 7 times negative 7. But what happens if you see this? Well, depending on your calculator, you'll get an error. Or if you're using your graphing calculator, you'll get non-real answer. Go ahead and try it if you don't believe me. I knew you would. But you will get an error non-real, because think about what a perfect square is. A number times itself. Okay, so a number times itself. 7 times 7 or negative 7 times negative 7. Can you ever get a negative number? No. Multiplying a negative by, or any number by itself, you'll never get a negative. Exactly. So that's why you get this whole error message. So this is where I comes in. I is a number. It's not a variable. I represents the square root of negative 1. That's what I is. Just like we have pi and it's a number, I is a number, and in college algebra you'll learn that E is a number. Crazy stuff. Okay. So, whenever you see an I, that is equivalent to the square root of negative 1. Now, the way we can work with that is I can actually now solve this problem of square root of negative 49. Instead of error or non-real answer, I can now break it down into, well, square root of negative 1, times 49. The square root of negative 1 is I, and the square root of 49 is 7. So this really is 7I is the answer to it. So the square root of negative 49 is 7I. Now, your calculator will do imaginary numbers if you have it in the right setting. And this is graphing calculators. Scientific calculators won't do this, but if you have a graphing calculator, it will. If you click mode up at the top of your screen, or it's towards the top, I think. I want to say it's next to the second button, yeah. Okay. Scroll down, it's probably going to be towards the bottom. you'll see the word real, R-E-A-L, and it should be highlighted. But just to the right of that, you'll see A plus BI. Move your cursor over on top of the A plus BI, hit enter, and then do like a second quit to go back to your home screen. All right, mode. Are you in the mode?
A second click to go at your home screen.
And go down towards the bottom where it says the word real. And just to the right of it, it'll say A plus BI. Right arrow so that that's highlighted now. And then now just go back to your home screen. So you can just do like a second quit or something like that. Just go back to your home screen. And now type in the square root of negative 49. And 7i should pop up. Now you can leave your calculator in this mode, and I would probably just leave it in this mode until after your test. You can still do everything else. If later on you're working with it and weird things start happening, just go back and change it, but it'll still do everything you need it to do. Now the nice thing about this is you can now work with I and check yourself in your calculator, and you can actually put in FOIL problems, division problems, multiplication problems, all that have the number I in it. Now, where's I on the calculator? It's second on the decimal point. If you look at your decimal point, there should be a little I above it.
Oh, shoot.
Okay? So whenever you want to use the number I, just hit second decimal point, and that's going to give you I. So, now let's go back and look at some of these I problems.